All right, in this lesson, we are going to be looking at the angles that are created between chords and secants. Okay, so the first one here, we're looking at the angles with chords. We're on page 17 right now. So the first thing we want to do in this diagram is we are trying to determine the measure of AED. That's the angle here at the center. So in order to do that, we're actually going to be looking at and going through these problems here that can kind of give us an example. So we're using our knowledge of inscribed angles and we're using our knowledge of the angles and degrees in a triangle. Okay, so first angle we're going to walk through is ACD. So here's ACD. That is inscribed to this 100-degree arc. So we know that an inscribed angle is half. So I'm going to actually place the number here as well. So let's put 50. So we'll say 1/2 of 100. That's how we got it. We know it's inscribed, so we know it's 50 degrees. Then we're looking for BDC. Okay, that's this angle here. If I trace that angle, it lands on the arc that is 140 degrees. So we would say that it is half of 140. So that is 70. We'll place that here on our diagram. Then we are looking for DEC. Here's DEC. That's this angle here. Little dots on there. Okay. So we know that a triangle has 180 degrees. So I would take 180 and we could subtract the two other angles here. So let's subtract 70. Let's subtract 50. So really we're just subtracting 180 minus 120. So we should be left with 60 degrees. So we'll place that here. Okay, and then the last angle, this was kind of the angle that we're searching for, the one that we're trying to find, but we're going through all these steps in order to do it. That would be this angle here, AED. Now we know that these two angles create a linear pair. They're a straight angle pair, so we could take 180 and we could subtract 60, and that would give us 120 degrees. That's right here. So if we look at the problems at the bottom of this page, they're all kind of set up similarly to that. The only difference is that with these problems here, you don't really have a triangle drawn. I mean, you could technically draw a triangle here and then find some of those angles. But what we're going to do is figure out, well, there has to be a shortcut. There has to be like a formula that can help us figure this out. So let's look at this in terms of a generalization. So it looks like A in this diagram is similar to our 100 degrees. So that means this angle here is half of whatever A is. So remember we did 100, then we got 50. So this arc here is A. This angle is going to be A over 2, half of A. And then this arc was essentially the one that we solved for next. So we would say it's half of B. So here we have B over 2. Okay, and then what we did was we took 180 and we subtracted these two angles here. So let's set that up as well. Or let me actually call this Y for now. Let's just give it a different name. And let's say that these three angles just add up to 180. So we can say Y plus A over 2 plus B over 2 equals 180. That's the three angles in our triangle here, adding up to 180. The other thing that we know that adds up to 180 are these two angles here. So X plus Y, or I'll do Y first so they're kind of in the same place. So Y plus X equals 180. So now if I look at my two statements that I have here, both of these statements have Y in common, and both of these statements have the 180 in common. So therefore, what that means is this A over 2 plus B over 2 has to be equal to this value here, X. So we should be able to substitute them in for one another in the equations, okay? So let's solve this in terms of X. So let's say X equals that. X equals A over 2 plus B over 2. And if we want to just create this as one statement, since these fractions, we want to add them together, they both have a common denominator of 2, we could just say that X is equal to A plus B all divided by 2. So now what we want to do is we want to test this formula with our original problem here. So in this case, this x, which we were solving for, this is x, it was 120. So let's solve for A, E, D. We would have then, our formula, so AED would have been our x degrees here. We would have taken 100 plus 140, added them together, divided by 2. So when we add these two angles together, that would be 240 divided by 2, and divided by 2, yep, we would get 120 degrees. Oh, I'm sorry. It's a little bit covered up from my face there. So yes, we added the 100, the 140 divided by 2. So now, instead of having to create triangles inside of each of the diagrams, what we can do is our angle here is just basically our two arcs that it goes to, that it's inscribed to, because these angles are vertical here. The two angles it's inscribed to divided by 2. So we tested out that method here. So let's try question 1 together down below, or our first question. So essentially we're using our same exact formula. This angle 1 is basically whatever x is, and this could be arc A and this could be arc B. So we could say that angle 1, or x in this case, is equal to A plus B all divided by 2. So we got 40 plus 52, that's going to be 92 divided by 2. And that would give us angle 1 equaling, I'm sorry, why did I call it angle 2? Angle 1 equaling 46 degrees. Okay. The second one here, you're going to set up in the same exact way. So angle 2 would equal half of these added together. It's almost kind of like finding the average between them. And then in this next diagram, you can kind of ignore the W. The W just shows you that that's where the center of the circle is. So we know it's not just a central angle, right? So what I would do first in this problem is let's solve for x. So here we have x. I would solve for x, adding these two, dividing by 2. Okay. And then once you have solved for x, you can figure out the measure for angle 5 by subtracting it from 180.